top of the track section. In this section, in this area of the geysers, it just so happens that the shape of the heat source comes fairly near the surface here. In fact, nearby here, it comes up from underground nearly to sea level, and we're at about 1,350 feet here. So we're only about 1,000 feet away from the very intense heat that supplies the geysers with energy. And so there's a fracture in the earth that sort of provides an opportunity for the steam from that resource to leak through the roof, you might say, and expel itself here. Really quite warm, and that's the only place they grow on Earth.
Really?
Yeah, that's called geyser.
Where'd you get that from? Yeah, that's almost the You need three things in order to get geothermal energy out of the ground in what we'll call a conventional state. You need heat, you need water, and you need a fractured reservoir such that the water can make it to the heat. That's what we have here at the geysers, and that's what allows us to produce steam and subsequently electricity from this location.
Altogether here, so are responsible for about good for will last 30 years. The very first commercial well drilled with the geysers in 1954 is that air takes the heat out of the water in the form of water vapor, and it blows it up into the atmosphere as natural water vapor that's just returned to the environment.
Oh, it'll certainly be sufficient to advance. Will it be enough to allow us to start commercially generating energy from geothermal? Probably not. It's enough that we can answer some important questions, looking at different circulating fluids, looking at different ways to connect the wells, which are all our important issues. So if we can solve the very large issues, then the smaller details are much easier to attack. So.
Maybe it's at your office.
Until they could get the rock to slide past each other.
because of the reduction in stress of the two pieces of rock against each other. If you can put pressure in the joint enough that the natural shear stresses.
If we pump water under pressure into the hole in the rock, it's going to try to push the rock apart. There's always a weak point and a crack starts to grow. And what's shown here on this black line, if you look close enough, there's a very small crack. So the fluid forced the rock open and came out to the side of the rock, and what we were able to do is, with stream potential, we could map out the crack growing, and we could actually see a precursor to the crack growing.
Tank, it doesn't really get stored there. It's just as water comes up, it gives it some room. It gives it a little bit of storage, but not a huge gallons.
Yes.